Hello everyone and welcome to PC Retro Tech. So in this week's video I'm going to be looking at animation on the IBM PC again, and a little bit later in the video I'm going to look at a new hard drive that I purchased for my 286 machine, but a bit more about that later. So I wouldn't normally do two episodes in a row on animation, but quite a lot happened since the last episode. You remember I showed you this animation of a tetrahedron tumbling through space with a little window that moves about that you can look at it through. And I said at the time that I didn't think you could draw the lines any faster than I was drawing them, since I'd spent an inordinate amount of time optimizing the code. So I mentioned this on the Vogons forum, which is a forum for retro PC hardware and games. And some people had a look at my video and my code, in particular someone who's quite well known. I won't embarrass him, but his online name is Reenigne. The joke is it's just engineer backwards, so reverse engineer. He had a look at my code and decided that there were quite a few things that could be improved. So he made a number of suggestions that would speed up the lines. So that's what I've been working on this week, at least the horizontal style lines. And so I'm going to talk a little bit about each of the improvements that he suggested and show you what the result is. So I'm starting here with the slower of the two line drawing algorithms, the one that I implemented for last week's video. And when I say slow, I mean it was 80% of the speed of the fastest one that I could come up with. But it was small and easy to work with. And I'm going to time this here. I think it takes 49 seconds, and what it's doing is lines of width 320 in the X direction, so horizontally across the screen, and I'm drawing every third pixel down on the right hand side, so you get this progressively more sloped lines as it draws them. There's 66 of them going down the screen here. So once I have a baseline for this, then I'll time each of the other tricks and explain how they speed up this already pretty fast line drawing routine. So the first trick has to do with the layout of the screen memory. You remember that all the even lines come first and then all the odd lines. And in order to move between an odd and an even line or vice versa, you have to add or subtract 8,192 bytes. And this was being done in a really ugly way with about 6 instructions because I didn't have enough registers. But Reenigne showed me that you can actually use the stack pointer as a general purpose register. And of course you have to turn off interrupts to do this because interrupts also use the stack. And that makes it unsuitable for some things like games and so on where you need keyboard input or whatever. But it does make a difference to the speed of the program. So that ran in 43.5 seconds. So it's certainly an improvement, and it all comes down to being able to do the update between odd and even lines in 2 instructions instead of about 6. So the next trick is to unroll the loops, and there's one main loop of course with 1 pixel per loop, and you can just do 4 pixels in a loop instead. Now just that on its own wouldn't speed things up very much, and in fact it doesn't. But if you remove instructions that are no longer necessary and take advantage of the fact that you no longer need to compute what you have to do differently in each iteration, but you can actually just do it because you now have each iteration separated, you can get a big speed up, and you can see that was much faster. It took 29 seconds, so a massive improvement over the previous 43.5. So the final trick for standard line drawing, you can see this is going really insanely quickly, is to bundle pixels together. And so if there are 4 pixels in a row in the same byte, then we just do 1 right here instead of 4. So writing to screen memory only when you need to is a really useful trick because the CGA memory is very slow. And I worked out that the time to do the write is when you move down a scan line. If your line algorithm is telling you to move down a scan line, you're obviously finished with the previous scan line and you can write that byte out. The only other time you have to do a write is when you get to the end of a byte. So remember, there are 4 pixels in each byte, so it can be that you actually end up only doing a quarter of the work just writing out once every 4 pixels if you had a completely horizontal line. And even for those other lines, just bundling pixels in this way makes quite a big difference. So we're down to 23 seconds, and that's less than half of what we started with. So it's amazing what these extra tricks can do. But we're not done yet. This is just standard line drawing. Take a look in the upper left-hand corner. You can see it's quite solid there because we're actually just writing pixels into the screen memory for these lines. But if I XOR instead, the lines will now interfere with each other, but it can go a little bit faster. And the reason for that is you lose a couple of extra instructions for computing. You don't have to worry about what was there before, you just XOR with whatever it was. And so that's a little bit faster, not a lot faster actually, because you still have to read and write to screen memory exactly the same amount of times. But the advantage of the XORing comes if you do a fast line blanking routine. So Reenigne had the idea that if you blank the line, you're doing a lot less work because you're just writing out zeros basically. So you can do that really fast compared to a normal line drawing. So in fact, this has to do twice as much work. It's drawing a blank line, then drawing a line, drawing a blank line, and drawing a line, but it takes less than twice the time. So twice the time would be 46 seconds, that's 2 times 23. This will only take 37 and a half. And that's to do with the very fast line blanking routine that I wrote. So here it is with XORing instead of just an ordinary line drawing. So this is blanking plus XORing, and this is a little bit faster. As I said before, you do save a little bit with XORing. It's a few seconds basically, and so the time goes down to 34 seconds with this approach, so it's about another 10% improvement. It's less than I thought it would be, but if you think about it, you're still doing the same reads and writes to screen memory as I mentioned before, so you don't expect to get very much improvement here. So the final trick is just to write into screen memory. Don't worry about what's there, don't worry about what's around you, just write the entire byte and just put zeros in the other bits of the byte that aren't relevant to your line. And this is fine if your background is black, because you're just going to be writing zeros where there are already zeros, and so nothing will change. So this would look ugly if this was being drawn over the top of a picture, so it wouldn't be useful for that kind of situation, but here you should expect things to go faster. Unfortunately, my current code for this doesn't go any faster than XORing, which is very surprising to me. It's still at 34 seconds, but at least we gave it a go, and this is a reasonable approach for some situations. Of course, it's not very good where lines intersect, because they'll be sort of blanking bits of each other out. So that's not perfect. XORing is better because you only really need to worry about points where the lines intersect, and those can easily be redrawn. Typically they're just usually vertices that can be redrawn because you have a list of them somewhere in memory. So that's all for the tricks, and I'd love to be able to show you the demo with all of these tricks implemented, but I still need vertical lines. So you might not have noticed, but all of the lines I had were horizontal with a little bit of a slope up or down. So you have to do the same for vertical lines with a little bit of slope to the left or the right before you have all possible lines. And our demo requires lines of any angle. So I'm going to keep working on that this week and see if I can come up with some really fast vertical lines. And so there'll be an update. I don't know whether there'll be a bonus video perhaps on Friday, or it'll be just next week in the weekend video. And we'll see how all of this comes together to give much smoother and much faster animation on the IBM PC. So the other thing I want to talk about is this hard drive that I bought this week. So let me show you that. So this is the hard drive that I purchased. It's a Kyocera 30 megabyte drive, It's a KC30A, and this was a pretty early drive. It's an MFM style drive, so that's the one with the two connectors on the back. It's not like an IDE where you just have a single connector. It looks more like a floppy drive actually, but it really is a kind of hard drive. And the reason that I bought this drive is actually mainly because of this front panel and the tray that it's in. Unfortunately, these are just really hard to get, and I have a black one in a 286 machine that I have bought, but it really doesn't match the machine. So the black ones usually go in IBM PCs, but these beige, well, it's actually more of a light brownish color almost. I'm not sure if that's original color or not. But yeah, this is much more suitable for beige PCs than the black ones. So I'm very excited to have this particular drive. Now I don't know whether it works or not, so I'm going to install it in my 286 machine and see if it powers up. I do have a MFM hard drive controller, and I'll give it a go and see whether it actually works. So I've got the drive set up and installed in the machine here, and it's just sitting on top there. You can see the light is on. It seems to be working at this point. It's a 615 cylinder drive with 4 heads and 26 sectors per track. It has 38 megabytes unformatted and 33 formatted. So I'm kind of hopeful that it's going to work. I don't know for sure that it's compatible with my controller. It's an ST412 interface, and it's an RLL drive, which I've not used before, so this is run length limited, which just sets the maximum number of bits that can be all the same. I'm not really too familiar about all the details. I'm just reading from the Wikipedia article there, but it does seem to be formatting okay using the low-level format utility, so I am hopeful that it is in working order at this point. So the format utility is running through and doesn't seem to be hitting any road bumps. It's also going very fast, which is a good sign. Usually when there's major problems with a drive, this will go very slowly, so I'm quite hopeful that this drive is actually in A1 condition. So unfortunately, this is what happens when I do a verify pass on this drive to check if it's actually working at all, and it just says that the requested sector is not found. So I don't know whether this is a problem with the drive itself or whether it's just not compatible with my controller. I haven't used an RLL type drive before, so I might need a later controller to actually make this work. Let me show you the weird sound that it makes when the machine starts up anyway. So unfortunately it looks like the drive might be cactus, and I guess that's all I can do really for this week. I'll look into finding a better controller for this, see if this is actually even compatible with the one that I have. And yeah, so that's it for this week, guys. Thanks for watching, and we'll see you in a later video. Bye!